All right, so today we're diving deep into circadian rhythms.
Ooh, exciting.
Yeah, we've got some fascinating research and historical observations to unpack.
Sounds like fun.
It's like we're exploring our own internal timekeeper.
Absolutely. It's a journey into the clockwork that makes us tick.
You know, I was really surprised to find out how far back observations about circadian rhythms go.
Oh, yeah.
Like way back, like that story about the tamarind tree.
Ah, yes. Theophrastus back in the 4th century BC.
It's amazing that even back then, people were noticing these patterns in nature.
It really highlights just how long humans have been aware of these cycles, these rhythms that govern life.
Right, and how that tree would open its leaves with the sunrise and close them when the sun went down.
Such a simple observation, but it speaks volumes.
It does.
Yeah.
But it makes you realize we've been aware of these cyclical patterns for a very long time. But it wasn't until much later that we really started digging into the science behind it.
Absolutely.
So jumping ahead to the 18th century, we have Jean-Jacques d'Autou de Meuron.
Ah, yes. His experiment with the mimosa plants, keeping them in constant darkness, that was a game changer.
Yeah, because even without the sunlight, the leaves still stuck to their schedule.
Precisely.
It must have been a real aha moment, right? Proving that there's this internal clock at play.
It was a pivotal discovery. It showed that these rhythms weren't just simple reactions to the environment.
So that's kind of the foundation for what we now call chronobiology, right? The study of all these biological rhythms.
Exactly.
Okay, so we know these rhythms exist even in plants, but what exactly defines a circadian rhythm?
Wow.
Is it just any biological process that repeats every day?
It's a bit more nuanced than that. There are 3 key criteria that a biological rhythm must meet to be officially classified as circadian.
All right, lay it on me. What's the first criterion?
So the first one is it needs to have what we call a free running period.
A free running period.
Yes, and this period has to be approximately 24 hours.
Okay.
So basically, even without any external cues like changes in light or temperature, the rhythm continues on its own. It cycles roughly every 24 hours.
So it's like an internal clock that just keeps ticking.
Precisely. Even in a dark, silent room, your body still has its own sense of time.
Wow, that's fascinating. So even without the sun telling us it's a new day, our bodies still have their own schedule.
Exactly.
Okay, so that's the free running period. What's the second criterion?
The second one is entrainment.
Entrainment. Okay, so what does that mean?
Think of it like setting your watch. Entrainment means that the rhythm can be adjusted by external cues.
Okay.
We call these cues Zeitgebers, which is German for time givers.
Like Dabers, I like that.
Yeah.
Yeah.
So things like sunlight, meal times, social interactions even.
So all these things can nudge our internal clocks to stay in sync with the outside world.
Exactly. These cues are crucial for keeping our rhythms aligned with the environment. Imagine if your sleep cycle was constantly drifting out of sync with the day-night cycle.
Well, that sounds like a recipe for disaster.
It would be chaotic, to say the least.
All right, so we've got the free running period, we've got entrainment. What's the third requirement for a rhythm to officially earn the circadian label?
The third criterion is temperature compensation.
Temperature compensation.
Yeah.
So explain that one.
This means that the rhythm maintains its approximate 24-hour cycle even when the temperature changes.
Right, because our bodies are warm-blooded and our temperature fluctuates throughout the day.
Exactly. And for the circadian clock to be reliable, it can't be swayed by these normal temperature fluctuations.
It's got to be a stable, independent timekeeper.
Precisely.
Okay, so we've got these super precise internal clocks ticking away inside us. But why?
That is the million-dollar question, isn't it?
Yeah, what's the evolutionary advantage of having the circadian rhythm?
Well, it's not just about adapting to external changes like light and darkness or knowing when to find food.
There's more to it.
Much more. Think about your body as a bustling city with all sorts of processes happening at once. Energy production, DNA repair, hormone synthesis, detoxification, you name it.
So many things going on.
And they all need to be carefully coordinated. The circadian rhythm is like the city planner making sure everything runs smoothly.
I like that analogy.
It ensures that the right things are happening at the right times. It optimizes efficiency.
Yeah.
Imagine if your body was trying to repair DNA while simultaneously trying to digest a big meal.
Oh, that sounds inefficient.
Extremely. And to understand just how deeply ingrained these rhythms are, we can look at a fascinating study with fruit flies.
Fruit flies.
Yes. These flies were raised in constant laboratory conditions for hundreds of generations. No light cycles, no temperature variations, just a completely unchanging environment.
So basically living in a time warp.
Precisely.
Yeah.
But guess what? They still retain their circadian rhythms.
Really? Even after all that time?
Yes, this experiment demonstrated that this internal timekeeping isn't just a learned response to the environment.
So it's hardwired into their genes.
It's an essential part of their biological makeup.
So if it's that fundamental in a fly, imagine how deeply embedded it is in us.
It makes you wonder, doesn't it?
It really does. But how did this internal clock even develop in the first place?
Well, there are a few compelling theories. One links the evolution of circadian rhythms to the Great Oxidation Event.
What?
The Great Oxidation Event. It was a dramatic shift in Earth's atmosphere that happened billions of years ago.
Oh, wow. Okay.
Oxygen levels skyrocketed. And while that was good for some organisms, it also created a new challenge.
Because oxygen can be damaging.
Exactly. Especially when combined with sunlight.
Right.
So this theory suggests that circadian rhythms evolved as a way to anticipate these daily changes in oxygen levels and protect organisms from potential harm.
Like a preemptive defense system.
Precisely. It's about synchronizing biological processes to minimize damage from the environment.
That makes a lot of sense.
Mm-hmm.
So it's not just about sleeping and waking. It's about protecting ourselves at a much deeper level.
Absolutely.
Speaking of sleeping and waking, those are definitely the most obvious ways we experience our circadian rhythms.
Right.
But I'm guessing it goes way beyond just feeling tired or alert.
Oh, absolutely. Our internal clocks influence a vast array of biological processes.
Like what else?
Well, think about your core body temperature hormone production, even things like cell regeneration.
Wow. So it's not just about when we sleep, but how efficiently our bodies function throughout the entire 24-hour cycle.
Precisely. Disruption of these rhythms can have some serious consequences for our health.
I bet. We'll definitely have to dive into that later. But first, I'm curious about something you mentioned earlier, the master clock.
Ah, yes.
Where is this internal timekeeper actually located?
The master clock in mammals is a tiny but mighty structure called the suprachiasmatic nucleus, or SCN for short.
The SCN.
Yeah, it's nestled deep within the hypothalamus, a region of the brain that controls a lot of essential functions.
So this tiny cluster of cells is basically dictating the rhythms for the entire body.
Pretty much. And research has shown that if you damage the SCN, it completely throws off the sleep-wake cycle.
Wow. But how does it receive information about light and dark if it's buried deep within the brain?
That's a great question. There's a dedicated pathway for light information to reach the SCN called the retinohypothalamic tract.
The retinohypothalamic tract.
It's a mouthful, I know.
Well,
But essentially, it bypasses the visual parts of the brain and uses specialized ganglion cells in the retina.
so we're not consciously seeing the light that sets our master clock.
Exactly. It's a subconscious process, a direct line of communication between the eyes and the SCN.
Wow, that's incredible.
Yeah.
But how does the SCN actually translate that light information into changes in our physiology? Like, how does it tell us it's time to get sleepy at night?
That's where the pineal gland comes into play. It's a small endocrine gland that receives signals from the SCN and releases a hormone called melatonin.
Ah, melatonin, the sleep hormone.
That's the one. The pineal gland produces more melatonin when it's dark, signaling to our bodies that it's time to wind down for sleep. And as light increases in the morning, melatonin production decreases, helping us to wake up.
It's like a beautiful little feedback loop.
It is. It's a symphony of signals and responses.
So we've got the SCN as the conductor, the pineal gland as the musician, and melatonin is the music itself.
I love that analogy.
It really captures the interplay of these different components.
It does.
This is all so incredibly intricate. It makes you realize just how much we take for granted when it comes to our bodies and how they keep time.
Absolutely. And it's not just humans. This system is remarkably similar across a wide range of species.
So it must be pretty fundamental for life on Earth.
It's essential.
So we know that disrupting this intricate system can cause problems.
Yeah.
You mentioned some studies with mice that had mutated clock genes.
Yes. Those mice experienced some significant issues. Obesity, altered glucose metabolism, even problems with fertility.
Wow, that's serious stuff.
It was. It highlighted just how crucial it is to have a properly functioning circadian system.
So if messing with those genes in mice had such dramatic effects, it makes you wonder about the impact of chronic circadian disruption in humans, especially with our modern lifestyles.
It's a valid concern and something we'll definitely delve into later.
Okay, good. Because I'm already starting to worry about my late-night screen habits.
We'll get to that. But first, let's address a common misconception about human circadian rhythms.
Oh, okay. Like what?
You've probably heard that humans have a natural 25-hour day.
Yeah, I think I've heard that somewhere.
It was a popular belief for a while.
Yeah.
So is our internal clock actually running a bit longer than a day?
Well, spill the beans. What's the truth?
Turns out it's not entirely accurate. Early studies on circadian rhythms often failed to properly shield participants from artificial light, especially in the evening.
Ah, so those artificial lights were skewing the results.
Exactly. Even dim light can delay the circadian phase, making it seem like our natural rhythm is longer than 24 hours.
Interesting. So what happens when you do control for light exposure?
Well, a very carefully conducted study back in 1999 by Harvard showed that when shielded from artificial light, the human circadian rhythm is actually closer to 24 hours and 11 minutes.
So pretty darn close to the Earth's rotation.
Exactly, which makes perfect evolutionary sense. Our internal clocks have evolved over millions of years to be in sync with the natural environment.
It just goes to show how powerful light can be, even in subtle ways, at influencing our internal clocks. It makes me think about all the ways our modern life might be disrupting these natural rhythms.
That's a great point, and something we'll definitely explore further as we continue our deep dive.
I can't wait. This is all so fascinating.
It is.
And I'm really eager to hear more about the impact of circadian disruption on human health and what we can do to protect these vital rhythms.
We'll delve into all of that and more coming up. Stay tuned. You know, it's not just artificial light that can throw things off balance.
Oh, right. What other things are we talking about?
Well, think about shift work.
No.
Millions of people working nights, sleeping during the day.
Right. Nurses, doctors, factory workers, all kinds of folks.
Exactly. Their internal clocks are constantly being challenged.
Yeah, trying to sleep when it's light out and be active when it's dark.
And studies have shown that long-term shift work is associated with increased risk of all sorts of health problems.
Oh, no. Like what?
Well, you've got things like cardiovascular disease, diabetes, even certain types of cancer.
That's scary.
Yeah.
Makes you realize sleep is not just about feeling rested.
It's essential for our well-being.
Absolutely. So what about those people who are stuck working shifts or traveling a lot, dealing with jet lag?
It's tough.
Yeah. Is there anything they can do to minimize the negative impact?
Well, there's no easy fix, but there are strategies that can help.
Okay. Like what?
For shift workers, maintaining a consistent sleep schedule as much as possible is key.
Even on days off?
Even on days off. It's about creating that regularity for your internal clock.
I imagine that's easier said than done with changing work schedules and all.
It definitely takes effort and planning, and then creating a truly sleep-conducive environment during the day is crucial too.
Right, because they're trying to sleep when it's light out.
Exactly. So make sure the bedroom is dark, quiet, cool as possible.
Like tricking your body into thinking it's nighttime.
Exactly. And then there's diet and meal timing.
Ah, right, because we talked about meal times being one of those zeitgebers.
Exactly. It's about keeping those cues consistent as well.
So try to eat at regular times and avoid those late night snacks.
Especially close to bedtime, give the digestive system a break overnight.
Makes sense.
Yeah.
What about jet lag? Any tips for those of us who travel across time zones?
Well, adjusting your meal times and light exposure to the new time zone as quickly as possible can help.
Okay,
Some people find light therapy to be effective too.
I've heard of that. Is it safe though?
It can be when used correctly,
Okay.
but it's best to do it under the guidance of a healthcare professional. They can help figure out the right type of light, the timing, the duration of exposure.
Right, so not just something to experiment with on your own.
Exactly.
So we've talked a lot about humans and animals, but what about plants? Do they have internal clocks too?
They do, and they're just as important for their survival.
Right, like that tamarind tree opening and closing its leaves with the sun.
Exactly. It's not just a passive response to light either. Plants can actually anticipate dawn and dusk.
Whoa, really?
Yeah, and they use this information to optimize their growth and development.
They can anticipate sunrise.
Ooh.
How is that even possible?
It's all about efficiency. It's better for the plant to start prepping its photosynthetic machinery before the sun even comes up.
So it's ready to go as soon as the light hits.
Precisely. There's even something called metabolic dawn, where certain pathways are activated in anticipation of daybreak.
Wow, so they're not just soaking up the sun. They're actively managing their energy based on their internal clocks.
Plants are full of surprises.
They really are.
Yeah.
And their circadian rhythms are just as complex as those found in animals.
It speaks to how fundamental this system is for life on Earth.
Totally. So we've covered a lot of ground here, from the history to the molecular mechanisms to the importance for all sorts of organisms.
It's a lot to take in.
It is. And I'm sure we've only just scratched the surface.
Oh, absolutely. There's always more to learn.
For sure. But before we wrap up, I want to circle back to circadian disruption in humans.
Okay.
You mentioned it can have a big impact on our health. Can you expand on that a bit?
Sure. So we talked about shift work and jet lag. but there's growing evidence that chronic circadian disruption can contribute to a whole range of health issues.
Like what kind of issues?
We're talking mental health problems like depression and anxiety, metabolic disorders like obesity and type 2 diabetes.
Oh, wow. That's a lot.
It really highlights how interconnected our circadian rhythms are with our overall health.
Yeah. So knowing all this, what are some practical steps we can take to support our circadian rhythms?
Aside from avoiding late night screen time,
Well, yeah, working on that one.
one of the most impactful things is establishing a regular sleep-wake cycle,
So going to bed and waking up around the same time each day,
even on weekends.
even on weekends.
It's like setting that steady rhythm for your internal clock.
Okay, consistency is key.
Absolutely. And then getting enough daylight, especially in the morning, is crucial.
So my morning walks are doing double duty.
Exactly. That morning sunlight helps suppress melatonin production and tells your body it's time to wake up.
Got it. Embrace the morning sun, avoid the
Yeah.
evening blue light.
Exactly.
Yeah.
What about meal timing?
Okay, what about it?
Try to eat your meals at roughly the same times each day and avoid eating late at night.
So no more midnight snacks.
It's best to give your digestive system a break overnight.
Right. And speaking of breaks, what about relaxation and stress management?
Yes. When we're stressed, our bodies produce cortisol,
Cortisol.
which can interfere with sleep.
Oh, I didn't realize stress could affect our circadian rhythms like that.
It can. So finding healthy ways to manage stress is key.
Exercise, meditation, spending time in nature, all that good stuff.
Exactly. It all helps support healthy circadian rhythms.
This is all so eye-opening. I never realized how much we take our internal clocks for granted.
They're always working behind the scenes, orchestrating this amazing symphony of biological processes.
It's incredible.
Yeah.
But it can feel overwhelming to think about all the ways modern life can disrupt these rhythms.
I understand. But knowledge is power. The more we understand, the better choices we can make.
That's a great point. It's not about being overwhelmed. It's about using this knowledge to take care of ourselves.
Exactly.
So what's one key takeaway you want our listeners to remember?
Pay attention to your body's natural rhythms. We're not machines meant to operate 24/7. We're creatures of nature, and our bodies thrive on regularity and balance.
I love that.
Yeah.
So by respecting our natural cycles and making choices that support our circadian rhythms, we can really improve our health and well-being.
Absolutely. It's all about finding that harmony.
Yeah, it's a whole new way of thinking about things,
Yeah.
right? Like tuning in to our bodies instead of just powering through.
It is. It's like rediscovering this ancient wisdom that's been buried under the demands of modern life.
So as we wrap up our deep dive, what are some final thoughts or key areas you think are important for people to explore further?
Well, one area that I find particularly fascinating is chronopharmacology.
Chronopharmacology. That sounds complicated.
It's actually pretty straightforward. It's the study of how the timing of medication can influence its effectiveness and side effects.
Oh, interesting. So like when you take a medication can affect how well it works.
Exactly. Our cells' sensitivity to various drugs can actually fluctuate throughout the day based on, you guessed it, our circadian rhythms.
So taking a medication at a certain time might actually make it more effective.
And it could also minimize those unwanted side effects.
So it's not just what we take, but when we take it.
Precisely. For example, some blood pressure medications seem to work best when taken at night
Oh, why is that?
because it aligns with the body's natural dip in blood pressure during sleep.
So it's like personalized medicine based on our internal clocks.
In a way, it's a really exciting field with a lot of potential to improve treatments and patient well-being.
Yeah, in the future, we might be getting prescriptions with very specific timing instructions.
Maybe even an app that reminds you when to take your pills based on your individual circadian rhythm.
That would be amazing. It really shows how understanding these rhythms can have real-world applications.
Absolutely. And beyond medication, there's also chrononutrition.
Chrononutrition.
Yeah, it's the idea that the timing of our meals can impact our metabolic health.
Oh, right. Like time-restricted feeding.
Exactly. Early research suggests that aligning our eating patterns with our circadian rhythms could be really beneficial.
In what ways?
It might help with weight management, blood sugar control, maybe even reduce the risk of some chronic diseases.
It seems like the more we learn about these rhythms, the more we realize how much they influence our lives.
It's true. And the more we can learn to work with them instead of against them.
Well, this has been an absolutely fascinating conversation.
It has.
Thank you so much for sharing your expertise with us today.
My pleasure. It's always exciting to talk about these things.
And to our listeners, thank you for joining us on this deep dive into the world of circadian rhythms. We hope you learned some interesting things and are maybe even a little bit inspired to take better care of your own internal clocks. Until next time, Stay curious and keep exploring.